Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore how we can create an API using Flask and then host that API in AWS Fargate, that is basically in an ECS cluster. Okay, because it is nothing but a service, it should be up and running 24/7. So we can use AWS ECS to host that particular API, and to use serverless technology, here I am opting for Fargate. And what that API will basically do, it will take user input, whatever user will be passing as part of post request, and it will ingest that in an Kafka cluster. Okay, so kind of an ingestion layer we are going to develop, and this is a very common pattern in our big data pipelines in many organizations, that some data from some particular source are coming via REST API, right? So here the user input, let's consider, or maybe here we are having some system which will generate the data, and it will be basically calling our API, making a post request, and along with that request it will be sending that data, and that we want to ingest in Kafka cluster. And from that Kafka cluster maybe we can load the data using Kafka connector in Snowflake or any cloud data warehouse system for further analytics and processing. Okay, so let's focus on this ingestion layer in this particular video, that how we can create a Flask API using which we can write the post request data in a Kafka cluster. Okay, and obviously because we are going to use AWS ECS, we require ECR in this pipeline as well. So basically we'll be creating a main Python file where our Flask app will be defined. Along with that we need to also create a Docker file, and then maybe we can push that in a GitHub repository, and based on this Docker file configuration, one Docker image will be created using GitHub action, which it will be pushing to ECR, and that Docker image I'll be basically using in the Fargate compute environment to run our Flask API. Okay, so this is the pipeline what we are going to implement in this particular video. Okay, so without any further delay we can start exploring the code section for this Flask API. So here if you see that I have written three important programs. One is Docker file, one is main.py. In main.py we are having the Flask app code defined, and apart from that, for GitHub action to create the image in an automated CI/CD manner, I have created a main.yml as well, which I'll be explaining. So let's go through this particular main code first. So I need Flask to create the Flask API, and basically this API, what it is doing, it is writing some data in Kafka cluster. So this is nothing but acting as a Kafka producer. So that's why I am importing the Kafka producer as well. Here I have given a topic name. You can basically provide that particular topic name where your Flask API should be writing the data. Here I am defining a simple producer with Bootstrap server, and value serialization we are just doing json.dump. So whatever post request data the user will be sending as a JSON, that we want to convert to string using json.dumps, and we want to write in our Kafka cluster, as simple as that. Okay, and then here we are creating our Flask app. Here we have created two simple routes. One is our base URL. If in that we are making a request, it will be simply returning hello world. Okay, and apart from that we have also created another resource path, that is /publish data. In this particular path it is allowing post request, and what it is doing, if you see, first we are doing message equal to request.json. So as part of the post request, whatever JSON data we are getting, that we are extracting in this message variable. And here we are printing sending Kafka message. This is just for debugging purpose, you can ignore this. Okay, and as part of the next step we are calling producer.send to send that particular message to our Kafka topic. Here we are providing the topic name, and the value part is basically the message one. Okay, and here we are printing the response, and here also printing sent message to Kafka. Okay, and if the message send is successful, we are returning success, except it is failed, so it will return error. And here we are running our Flask app in port 50,000. So this is our simple Flask app code, and if you check the Docker file, it is very simple. We are taking a base Python Alpine image, we are creating a directory called /app, that will be basically our working directory in our Docker file. And here we are upgrading pip, installing Kafka Python, because Flask app is acting as a Kafka producer. So we are importing from Kafka, import Kafka producer, and to work with it we need to import Kafka Python. And apart from that we are installing Flask also. So maybe I can install this version, pip install Flask. and we are copying everything from my current working directory to the app folder, which is our working directory within the Docker container, and we are executing this command python main.py. So it will be continuously running our this particular main file, and it will be acting as a kind of service which should be up and running 24/7. If due to some reason the service or the task fails, we will be configuring the desired task count equal to 1, so that automatically one new service or task will be up and running as soon as the earlier one will be failing. Okay, right? So this is our main and Docker, and if you check our GitHub action, it is also very simple. Here we have given this name. On push we are going to run this particular GitHub action. Basically on each push event it will be creating a new image in our EC repository, and we are using Ubuntu latest to run this particular GitHub action. And as a first step we are doing checkout, then we are configuring AWS credentials, which is pretty much simple. You can put your own AWS access key and secret key here, and I am using the North Virginia region, that is US East 1. Okay, and then as part of the next step we are logging into our ECR account, and here we are basically building the Docker image using the Docker file, and we are pushing this in this particular repository. The repository name we have given ingest layer. You can give any name based on your requirement. Okay, and tag we are providing github.sha, so that each time the image will be having a new tag attached, because github.sha basically changes in its each run. Okay, right? So this is pretty much a simple GitHub action code. So here what I will do, first I need to create a Kafka cluster to make the code runnable, and to create a Kafka cluster this time I am going to use Upstash. Okay, so here you can basically log in as part of free trial account, and then here you can create a simple Kafka cluster to do different POCs and experiments. Okay, so I'll click on create cluster. So here it will be asking for the cluster name. Here I will be giving the name something like demo YT Flask test, and I want to create in North Virginia. That is fine, because our this Flask app will also be sitting in North Virginia. So if our Kafka cluster is also in same region, then the message writing operation will be at least faster. It will be having lesser latency, right? So I'll be copying this particular name for future reference, and here I'll be creating the cluster. Okay, so it is going to take few seconds. Let's wait for that, and it is done. Now as part of the next step, it will be asking you to create a topic. Okay, so let's see whether we have given some topic name or not. Yes, we have given this topic name captured data. So that topic name only will be putting here. Partition count 1, that is fine. If you want to change some other properties for this Kafka topic, you can do this using these options, like cleanup policy, retention period, for how many days you want to keep your messages in this particular Kafka cluster before it get deleted or before compaction happens. Those kind of things you can configure here. So I'm not going to those details here. Without any further delay, we'll simply create the topic. Okay, right? So here all good. Now here you will be getting the username and password, and for different clients how you can connect with this Kafka cluster, that will also be shown. So here we are working with Python, so I'll be choosing that. So here two libraries it support. One is Kafka Python, one is Confluent Kafka. I am going to use Kafka Python, so I can basically simply copy this producer code from here. Okay, so here I can paste this one, Kafka producer, bootstrap server. First we are defining, then SASL mechanism, basically authentication mechanism in our Kafka cluster. Those things are mentioned. The username and password is star. We need to basically take the value from here and paste those here. Okay, username, and then here password I'll be copying. Okay, cool. And here you can see the serialization is not mentioned, so here I'll be taking the serialization also, right? And maybe I can delete this old producer code. Okay, so this way our Flask app, which is going to write the message in Kafka cluster, is ready. And what it will write, it will basically write whatever user is providing as input. Okay, cool. So here what I will do as part of the next step, I'll be going to my repository and I'll be creating a new one. And here repository name I can maybe give ECS ETL ingest layer. Okay, so here, because this particular process is going to help us in ETL process, because this is kind of for extraction layer we are building this API, right? So I am giving this name as ingest layer, and here this ETL process we are going to build with the help of ECS service. So I have given ECS ETL. Okay, right? So let it be private. Description, if you want, you can put something. I am not changing those. I will be creating the repository. So that is done, and here you can create a new file or upload an existing one. So I can click on create a new file, and then the file name I can give main.py. Okay, so let's put our Flask code first. So here I have given the code. I'll commit this. Then apart from that, I need to upload the Docker file, and here I'll be going to the Docker file, copying this and paste that here. Okay, so Python main app.py. So this will be running when our container will be up from the Docker image, right? So hopefully this should work. So I'll commit these changes. And then another thing which is required, that is GitHub action. Okay, but before going through the GitHub action, what we need to do, we need to make sure that this repository exists in our ECR repo. So here I will be going to Elastic Container Registry, and I'll be creating a repository, and let it be private, and here ingest layer name I have given, and create this repository. So repository is created, cool, and I can now copy this particular GitHub action code in our repository. Okay, add file, create new file. So .github /workflows/main.yaml. Okay, so here basically this is the folder structure we need to follow to run our GitHub action. That is, within .github folder we should be having workflows. Within that we can put our YAML code, that is this thing, and I'll simply commit the changes. Okay, so as soon as I will commit, what will happen, I can go to the actions. This is our main page, and if I go to the actions, here you can see the create main.yaml action is triggered, which is hopefully going to push an image in this ingest layer ECR repository. Okay, so let it run. Till then what I will do, I will go to ECS, okay, to launch a Fargate instance or cluster. So console, and here Elastic Container Service, I will opt for it, and then create cluster, cluster name ECS ETL ingest layer, some name I have given, let it be AWS Fargate. Okay, tags I am not providing anything. If you want, you can put it, and infrastructure AWS Fargate is fine. Encryption is not needed, keeping all other properties default. I'll simply create this cluster, and here you can see our cluster is in creation process. Let's wait for some time, maybe I can refresh. So here you can see this cluster, it is still in progress state, so that's why it is rotating. Let's wait for some time until our cluster get created, and by the time if I go to my workflow, here you can see workflow status is success. So hopefully in our ECR or Elastic Container Registry, in this ingest layer repo, we should be having our image, and if I refresh, here you can see this image is pushed. This image basically will be using to launch a Fargate service or Fargate task, where our Flask app will be continuously running, and which will basically take post request and write the data in Kafka cluster, right? So let's see, and here you can see our cluster has been successfully created. Currently 0 services are there, so I can go to the task definition to create the definition for our service. Okay, so create new task definition and give the name as ingest layer Flask Kafka something. Launch type Fargate, that is fine. Operating system, it is fine. CPU memory I am not changing because this is just a POC. Task role, very important. So task role, here I can choose ECS task execution role. Okay, so let me show you that one as well. So I can go to IAM, and then I can go to roles, ECS task execution role, that is basically this one. You'll be seeing that in your account also this kind of role should be there. And here if you see the policy attached with it, it is AWS managed policy, which is Amazon ECS task execution role policy, and this policy has all the necessary permissions which is required to launch a task in our ECS cluster. Even pulling the image from ECR repository, those kind of permissions also available here. Okay, so I can choose that one only. This is our task execution role, that is fine. Container name, I can put something Flask ingest Okay, and now here we need to provide the image URI. So for that I can go to the ECR, and this is our image. I can click on it and click the URI option and paste it here. Okay, essential container true. And now here we need to do the port mapping. So if you observe in our code here in main.py, we are running the app in port 50,000. Okay, so container port 50,000 I can say should be mapped to the host port 50,000, so that from our host machine where our Docker container is running, there if I make a request to the 50,000 port, it will be forwarding that to the container port 50,000, and that way our Flask API will be accessible. Okay, so port mapping we have done. And then here keeping this particular property as it is, environmental variable not needed, logging is fine. And here if you want you can put some other log configuration option. I am keeping that unchanged and keeping all other properties default. Here what I will do, I will create the task definition. So this task definition basically defines what Docker image we need to run, but where we need to run, that is not at all mentioned. And it has also mentioned what Docker container role basically it will be using while running that image, right? So those kind of informations we have defined. Now as part of the next step, we need to launch the service within our cluster. So I'll go back to cluster, click on cluster, and here if I scroll below, here you'll be getting a service option. So I'm going to launch a service. So in this cluster we want to launch, this should be Fargate type. Okay, and service or task. So task is having short span of life, but service is long running, so I'll be opting for service. Okay, family. So family is basically here in the drop down you can choose the task definition family. Just now we have created this one, and the revision we are having only one definition, so I'll choose the latest one. Service name we can put something Flask app ingest layer, something like that, and desired task, it is 1. So this is very vital, because if due to some reason our service encounters error and it get terminated, automatically ECS will launch another task with same task definition whatever we have defined to have our API accessible. Okay, so that way our business will not be impacted. Cool. And service container, those things we can keep as it is, and without any other changes we can create this particular ECS service. Okay, so now it is going to take some time in the deployment. If I scroll below and if I refresh in the service section, here you can see that the last deployment step is in progress. Even if you want, you can go inside that and go to the log section. Eventually here you will able to see all the logs when it will be pulling that image from ECR repository, and it will be starting up our code. Okay, so let's wait for some time till it become in ready state. Okay, we are getting this message that our service has been deployed successfully, and here you can see deployment completed, 1 is running, 0 pending, that means none of the tasks are in pending state. So now if you go to the log section, and here you will see all the informations like serving flask app.main, debug mode off, running on this particular URL, but this is basically its local IP. We cannot use that. To make this particular Flask app accessible, we have basically mapped the 50,000 port of our container with the 50,000 port of our host, right? So from that public IP we can access it. So for that we can go back to this service, and here in task section, here you will able to see this is our task running. You can go inside that task, and here you will be getting the public IP. Okay, I can paste that public IP colon 50,000. If I put and hit an enter, here you will be getting hello world. So why this hello world is coming? This hello world is coming because of this particular code. Okay, that if we are making any GET request to this particular base URL, it should return hello world, right? So that means our Flask app is healthy and it is properly working. Now we will be testing whether if we make a post request to the endpoint / publish data, then whether it will be writing that message in Kafka cluster or not. And in our this case the cluster is this one, right? So I can click on messages here, and I can choose a topic where some new messages we want to monitor, and here I have chosen our topic, that is captured data, which we have defined here also, right? And here you can see it is checking whether any new message available in this topic or not. Currently no new message is there, so let's make a post request to that Flask app. So here I can paste this particular endpoint. Along with that, in our case, the resource path is published data. So I'll be choosing that. Okay. And then here, key value pair, I need to put something. Suppose hi and colon, this is the first message. Okay, right? And here we have chosen post request. That is fine. Let's try to make a send request. So here you can see status is success. And if I go back to our Kafka cluster, here you can see one new message few seconds ago got published. Currently it is 6:42 p.m. and here also timing what it is showing, it is 6:42. If I expand this, here you will be able to see, hi, this is the first message. Okay, like this way you can pass any messages. Like for example, I can pass A and then colon B comma C colon D. Okay, right? So this is one key value pair, this is another key value pair. We are passing the JSON data as part of our post request body and we are making a send request. Again it is 200, and from where this OK 200 success is coming, this is coming from here, return success, right? And here what we will do, we can go to our Kafka cluster and here you can see another message got published at 6:43 because currently it is 6:43. If I expand that, here A colon B C colon D, that information is coming. So basically whatever user is passing as part of post request body, the Flask app is publishing that data in Kafka cluster. So I hope this particular whole pipeline you understood, and the important learnings out of this are how we can create an API using Flask for data ingestion in our Kafka cluster, right? Earlier I have already shown you this example with AWS Lambda and API gateway. That is, we have created an API using API gateway, and that API gateway is triggering Lambda. Lambda is publishing that message in MSK or some Kafka cluster. But suppose you want to create a service kind of thing, then you can opt for Flask and Fargate combination. Okay, because here we want to run that particular service or that API in serverless manner 24/7. So one of the best option to choose is AWS Fargate. Right? I hope you understood this. This is all for this video. All the codes and reference links I'll be providing in the description box for your reference. If you have any doubt in any part of this video, please ask in the comment section along with the timestamp. I will try to reply back ASAP. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.